Question 3.3 is all to do with how a valve A, which is the atrioventricular valve in the figure 2, which was the diagram of the heart, maintains a unidirectional blood flow. So this is where we need to think about the pressure changes in the chambers and how the valves help control the blood to flow in one direction. So if we look back at the graph that we had in our pack when we did about mass transport in the blood, we saw about how pressure affects when the valves open and when they close. So at the point where we have a crossover here, we can see that the pressure in the left ventricle starts to increase due to the left ventricle contracting, and the moment it goes higher than the pressure in the left atrium, then that valve will close. The atrioventricular valve will close. As the pressure in the ventricle then increases, then the semilunar valve will then open, because at this point here, the pressure in the left ventricle is higher than the pressure in the aorta, so the blood will flow from the left ventricle into the aorta. As the pressure in the ventricle decreases, as it starts to relax, then the pressure in the left ventricle then drops below the pressure of the aorta. So in order to prevent backflow, then the semilunar valve will then close at this particular point so that the blood will not flow backwards due to the pressure in the aorta being higher than the left ventricle. As the pressure decreases, then we get to a point where the pressure in the atrium is now higher than the pressure in the ventricle. So at this point here, you will have the AV valve, the atrioventricular valve, opening so that the blood will flow from the atrium into the ventricle, because at this point the pressure in the atrium is higher than the pressure in the ventricle. So we have closed, open, which you can remember as COCO. C-O-C-O. So then going to our particular question and thinking about the valve in figure A maintaining unidirectional blood flow, the mark scheme would like us to explain why that valve will open and close. So it's the idea that that valve will open when the pressure in the left atrium is higher than the ventricle, which would cause that valve to open, the AV valve to open, or when the pressure above the valve is higher than the pressure below the valve, it will open, because blood would always like to flow from a high to a lower pressure. For the second marking point, it's talking about when the valve would close. So the valve would close on the opposite side of the diagram. So when the pressure in the left ventricle then becomes higher than the atrium, then the valve will close in order to prevent backflow. Or when the pressure below the valve is higher than above the valve, it will close. If you have put the wrong valve for the first part of the answer and you have described it as the semilunar valve, the error will be carried forward in this question, but you must then be talking about the pressure between the left ventricle and the aorta. So therefore the semilunar valve would open when the pressure of the left ventricle is higher than the pressure of the aorta to allow blood to flow through, and the semilunar valve would close when the pressure of the left ventricle drops below the pressure of the aorta. It's always important in this particular question, and when you're talking about pressure changes in the heart, to always try and use comparative words such as higher or lower, and to always say which chamber is higher and what it is higher than. So for example, the atrium is higher than in the ventricle.